Hello, guys. Can you hear me?
Yes, we can.
Yes, we can.
How are you guys doing?
Good, and you?
Fine. All right, let's start. Today we continue from where we stopped last time. I'm hoping that by now you have printed those two documents I mentioned last time. This one here, for the normal distribution table. This statistical tables. What about this one here? And the other one, procedure charts, very important. Like I say, we'll be using especially the statistical table from now on. Now let's begin. Okay. Let us begin. Okay, let's see. So we'll begin from here. Say finding specific Z value for a given area. On today I showed you how to find the Z values, find the areas or the probabilities when you are given the Z value. Now we're going to do the opposite of that. When you are given the probability or the area and you are asked to find the Z value. So we are going back, backward, that is the opposite. The first example we'll do is this one here. It says, find the Z value such that the area under the normal distribution lies between 0 and Z. Okay, between 0 and Z. Now, they didn't tell us whether it's on the left side or right side, but I'm assuming that it is on the right side since Z is, says Z, they didn't say negative Z. That means let's assume that it's on the right side. So, and the area is 0.2123. So to do this, first of all, as usual, I will put the solution here, and then I'll write the area given. Then next is to draw the chart. Okay, area given is 0.2123. Okay. Now, so we are asked to find the Z value. Again, like I said, they didn't say whether it's on the left side or right side, but because this Z is positive, I'm assuming that it's on the right side, on the positive side. And it says lies between 0 and Z. So let's draw the charts. 0, and then have Z we are looking for. Now we can put the chart here. We have the insert the chart, the line here, and then of course the bell curve. I didn't get it right. It's too small. Let me try it again. The bell curve. Okay, I got it right here. All right. Okay, that's better. Then make some adjustment, and then some a little adjustment, Z value. See, between 0 and Z. So we're gonna put the center line. It's here. And say between I think between 0 and Z. This is 0 and Z. Okay. Now, next is to put the line that represents Z. Okay. This is the line right here. So this is between 0 and Z. Okay. Now let's share it to show it. So you can share it. Faster way of sharing it. I can use this. So this is the area we are looking for here. Now, once you have it drawn in this form, next thing to do is to go to the procedure chart, the way I showed in the class on Monday. What chart? Let's look at the chart that looks exactly like what we have here. This is what we have here, our drawing. See? Between 0 and Z. And you will see that the chart that looks like that is this one here. And make it bigger. Oops, yep, right here. So that's the one that looks like this one here. This is this one here. Between 0 and Z. And it says, look at the Z value to the table to get the area. That's it. That's what it says. And that's what we're going to do. So we go over there and look at it again. See? So you say look at the Z value to get the area. Nothing else. Look at the Z value to get the area. So look at this one here. So let's look at the Z value. Remember that the Z value we are giving, I mean the area we are given is 0.2123. So with a 0.2123. Look for it. This time around, we'll be looking inside the table, not from outside. We'll be looking for the value of this 1.2123 inside the table. If you don't find exactly this number, then you choose the one that is closest to it in size. So we have it right here. I gotta write it down. Let me write it down so I can remember. Let me write it down. 0.21. 0.2123. Okay, let's go and look for it. Okay, we have it right here. 2123. Oh, I see it right here. It's right here. We're lucky. So now you follow it to the left. See the 0 here. So you follow it to the left. You see 0.5 and you follow it up 6. I mean 0.56. 0.56. 0.56. That's C. Any question to this? Any question on this?
No.
Good. Excellent. Excellent. So now let's do another one. Some people just came in. Let me see who are they. Oh, okay. They're in. Okay, good. Look at the second one. Which is this one here. It says find the Z value. But this time it says to find this, it gave us the direction. It said find the Z value to the left. Okay, play. Find the Z value to the left of the mean. See? Such that the area under the normal curve is between 0 and Z value is this. See? Because this one we just did right between 0 and this. Yeah. If let's say this one is negative, that means it should be on this side, on left side. But this one is saying find the area, find the value to the left. Find the Z value to the left of the mean, so that the area under the standard normal distribution curve between 0 and the Z value is 0.3460. See? Yeah, almost the same thing they say here. Now, but it says find the area to the left. So we're gonna be conscious of that. So now we draw it. It's a solution. Solution. area we are given is area was given as 0.3460. Okay. Now Z value we're looking for is what you are looking for. So I'm gonna just put it right there. Now we can make our chart. Now it says Z value to the left. That means it's on the left side. That's negative Z. Negative Z. So that the area between the Z value and the 0 is 0.3460. So we're gonna just put the chart right here. Okay. Let's draw the chart. Okay, this is the Z. Okay, now put the bell curve. Okay. So make some adjustment. All right. Now, some more adjustment. Okay. Okay, now we can adjust this as well. So you're gonna be before you can now put the center line. The center line, maybe this one. Now I say find the Z value to the left, see negative Z, and it says what's it gonna be negative Z, right? So we have so that the area to the left, so that the area of the curve between 0 and the Z value is 0.2. So now between the Z value and the area between the curve and the Z value, okay? Let's just put this right here. Then we can shed it. Okay. Faster, we can shed it. Yeah, okay. Okay. Now we can now find the Z value. Find the Z value. Okay. They told us 0.3460. Let me write it down. 0.3460. Now, let's look for the chart that looks exactly like this one. Okay. We go to the where we can find the procedure chart. Okay, this is procedure chart. Again, we have this type. See? This time around, we have this one. Negative Z. And you also look at the zebra to the table to get the area. That's what they said. Okay. So that means we can look at the zebra to find area points. Remember, the area they give us is area they give us is 0.3460. So look at 3460 here. 3460. I got 32. The closest one I found was 3461. I also found 3438, which is very far away from 3460. I equally found 3485, which is also very far away. Closest is this one. So we follow it to the left. You can see this. We follow this to the left. 1.0 and up 2. 1.02. Now, because it is on the left side, you gotta be negative 1.02. Okay. So you have negative 1.02. Negative 1.02. 1.02. Okay. That is your Z value. So now it depends on how they, then we might ask it in different form. Like this one says, find the Z value. The area under the find the Z value so that the area under the normal distribution curve lies between 0, that lies between 0 and Z, and the area is this. This one is less clear, but this one is more clearer. And this other one we're about to solve now. It says find the area, find the z-value to the left. See? Z-value to the left. Okay. Z-value to the left of the mean. Again, they give us the direction such that 98.87% of the area under the normal distribution curve lies to the right of it. Lies to the right of it. Okay. Now, we're going to make a solution. The area they give us is, okay, the area they give us is 98.87%. Okay. 98.87%. Which, when you change it to decimal, it's going to be 0.9887. And z-value, the z-value, z equals, now let us find the z-value. Now we look for this number in the chart, but before you can do that, let us draw the chart first. Okay, we have it says find the z-value to the left, so on the left side, so it's gonna be negative z. Got 0 here. Now we can now put our drawing, make our drawing. So draw this, put our x-axis, then put the bell curve. Okay, this a little bit. Okay. Now put the center line. Okay, the center line. I put the center line right here. So you say z value to the left, so that 98.87% of the area lies under the curve. Okay. So now and z curve is the z value is right here on the left side. So we can put right here. Right from here, we have it right there. There's a 98.87%. That means the lies all the way to the left. So we got 98.87%, 98.87%, okay, of this lies all the way to the left. So we're gonna shed the whole of that. We said it didn't say between, unlike the one we did before, it said it lies between 0 and z. But here it says that 98.87 lies to the right. That means all the way to the right. Which means that we're going to shed all the way to the right in this case. So we're going to shed from here. Okay, from here, all the way to the right. It'll be shaded. Okay. Now we can answer the question. Now let's go to the procedure chart. Look for the chart that looks exactly like this one. We go to the procedure chart. It's right here. And look at what we have in our drawing. Let's look at it again. See, from here all the way to the end. So now, and from the procedure chart, you can see that the chart that looks like that is this one here. This one. And it says, look up the z value in this table to get the area, add 0.5 to it. So that's what we're going to do. So let's find the z, let's look at this z value. Now, Now, since now the direction it gave us here, okay, is the what we do if we are looking for the z value, okay. And you have that is if you're looking for the z value, you take that direction. Now, but since we're doing the opposite, we're gonna do the opposite of that. Why? I'll explain in a minute. Look at this z value they gave us, 0.9887. If you go to the table that we have, this table here, you will discover that we don't have 0.9887 there. The largest number we have there is 0.4999. So that means we're going to do the opposite. Instead of adding 0.5, we're going to subtract 0.5. So we can be able to find this. Since we cannot find 0.9887 there. So I'm gonna do this. I'm gonna say okay. So we're gonna have this to put the arrow here to show that we did okay, the opposite, which is okay, 0.59887 minus 0.5000. Okay, and that will give us we can do that on the using calculator. 0.9887 minus 0.5000. Okay. Now we can do that to the calculator. And our calculator is located here. So I'm going to share it with you. 0.9887 minus 0.5000. Okay. It gave me 0.4887. So instead of looking for, let me write it on the paper first. 0.4887. So instead of looking for 0.9887, which we cannot find in the table because the maximum we have there is 0.499. So instead of looking for that, we'll be looking for 0.4887. So we're going inside the table, 0.4887. Oh, you're lucky. Right here. You can see it right there. See it right there. Follow it to the left. 2.2. Up 8. So 2.2 and up is 8. So you're going to be 2.28. 2.28. Now we go and put 2.28 there. 2.28. Now, because it's on the left side, so it's going to be negative 2.28. Any question to that? Any question? Yeah, no question. Good. Now, at this point, we're ready to do the application of this. It's called standard normal distribution. Now, a standard normal distribution simply means a normal distribution with a mean of 0 and a standard deviation of 1. A mean of 0 and a standard deviation of 1. That's what they call a standard normal distribution. Now, all normally distributed variables, we can transform them into standard normally distributed variable using this formula here. Z equals S minus mean divided by the standard deviation. Where X represents the data value, Z represents the standard score, mean represents the mean, and then delta symbol represents the standard deviation. Okay. Now, so we can apply it here. Look at this application. This application of normal distribution. It says let me move this application down so we have enough room. It says here, the monthly utility bills in a city is normally distributed with a mean of $100 and a standard deviation of $12. A utility bill is randomly selected. Find the probability that the utility bill is less than $70. B, find the probability that the utility bill is between $90 and $120. And C, find the probability that the utility bill is more than $140. So let's start with A. A says, find the probability that the utility bill is less than $70. Now, the first thing we do is to list out the information. It's kind of the summary statistics that we are given about this question. First of all, we are told us that the monthly utility bills are normally distributed with a mean of $100. Let me take this symbol for mean from here. And let me take both of them because it make it easy for us to proceed here. So part A, so you have this right here. Mean is $100. And then the standard deviation is $12. Oh, excuse me, $12. What the standard deviation is. So these two information are very important. Now, part A says find the probability that the utility bill is less than $70. So in that case, our X is $70. So the first thing now to do, the second thing to do now is to transform this X using this formula here. Okay, let's copy it up here. Copy it. You need to transform that formula. That means that number, which is 70. Transform it, change it into it is an S value here. Change it into a Z value using this formula here. Okay. So what this means is that you're gonna plug in these numbers in here. So you have equal. Let me make this in 18 so that we have okay, good. 18 says X minus mean over standard deviation. So that means our X is 70 minus mean of 100 divided by standard deviation of 12. Okay. Now let's do it. I have right on paper 70 minus 100 divided by 12. So it says 70 minus 100 divided by 12. So let's go and put it on the calculator. Got 70 minus 100 divided by 12. Negative 2.5. See, negative 2.5. So I'm going to write it negative 2.5. 2.5 basically, because Z has always two decimal places. 2.50 negative 2.50. See, now it is no longer X. Now it is now a Z. And it is no longer 70 now. It is now negative 2.5, which means that the probability that the bill is less than 70 becomes, okay, the probability that Z is less than with this right, the symbol is less than negative 2.5. Okay. So instead of looking for the probability that the bill is less than 70, we will be looking for the probability that is less than negative 2.5. And then to answer that, we now need to draw this chart. Okay, the chart have negative 2.5. Then we put our x-axis line here. Okay. So we can put the bear curve. Okay. And make adjustments here. Yeah. Now, maybe I'll bring it down a little bit. Okay, a little bit down. Yep, that's it. Now, put the center line. Oh, that's 0. Zero will be here, not 0. So I'm going to move this a little bit. Okay. Now, less than 17. Let's put it now. Let's put the center line. Which is right here. Then to say between less than z, negative 2.5. Let's put the line that represents z, negative 2.5, which is here. Okay. Now it's less than that. That means it's on the left side. So we can now shade the left side. Okay. Now, after doing that, we now go to the table of normal distribution to find out one that looks like this. Remember when it's on this form, we say that it's at the tail. Okay. I remember I mentioned that on Monday, we said it is at the tail. Okay, left tail this time around. Okay. Now we go to look for it, the procedure chart. Okay. Procedure chart is right here, and I'm gonna share with you. You will discover that the one that looks like it is this one here. This one. Make sure I see it. Okay. See, because what we have is this. See, left side shaded. So the procedure chart will be you say this one. And they say look at the zebra to get the area. Subtract the area from 0.5. Which means we're gonna do 0.500 minus, now let's look for the area. Let's look for negative 2.50. I remember I mentioned in the class that if you're using the table we are using for this class, let's switch to this one. Negative sign simply tells you that it's on the left side. So you don't have to, look for negative 2.5. Okay. To look for negative 2.5. This negative 2 means you go here, negative 2.5. That means when you go to the chart, look for negative, just 2.5. So this table is not cumulative. Okay. We look for 2.5. See, 2.5 is right here, 2.5. And remember, this is 2.50. So you're looking for 2.5 under 0. See, 2.5 under 0. So you have 2.5. It's right here, under 0. This is 0 right there. So 2.5 under 0 is 0.4938. P z less than negative 2.50 is 0.5 minus 0.4938. And that will give you the answer, 0.4938. Okay, so we're going to put it on that one. So 0.4938. That will give you the final answer, 0.5 And then we have 0.5. 0.5 minus 0.4938. Give us 0.0062. Okay. 0.062. That's the answer for that question. So that the probability that the utility bill will be less than $70 is 0.0062. Any question to this? Any question, guys?
No.
All right, let's try another one. It says find the probability that the bill will be between $90 and $120. In this case, we are transforming two things, $90 and $120. Okay. Now that's what we remember. The mean is still the same. Mean is still $100 and the standard deviation is still $12. So I'm gonna just copy this and put it from the part B. Okay. Mean is still that, and then the standard deviation is still $12. Now, like this time around, we have transforming to the $90 and $120. So you're gonna have X1, okay, as 90, and X2 as 120. X1 equals 90, and X2 equals 120. Okay. So again, the transformation formula is right here. This formula right here. So I'm gonna S minus mean divided by standard deviation. So you have equals. Now now there are two of them. We're gonna do twice. Okay. So you gotta do for X1, okay, and F for X2. Okay. So let's start X1 first. X1 equals and let me get the two formulas from it will allow us to get the characters for them. So I'm gonna get the formula using another the other workbook, then transfer it to this one. So that workbook that I'm talking about, let me get all the information here, write them down, and then take you to that workbook where you can get it. So this one will not allow us to use it. You got mean is 100, standard deviation is 120. Okay. So let's go to that workbook. After we get it there, and then we'll put it back here. So I'm taking you there in a minute. Right here. So you have so you have this X1 or Z1. Okay, equal. I'll make it big. 18 should be good enough. Z1 equals okay, we have X1. Okay. Minus mean. Okay. The mean is given here. Okay, divided by standard deviation of this. Okay, which is equal. Now we can put the numbers in. We got S1, our S1, if you remember, before we came to this side, our S1 is 90 and our S2 is 120. Okay, so have S1 is 90 minus 100, which is the mean, divided by standard deviation of 12. Okay. All right, let's put this in the calculator. Z1 was to 90 minus 120. 90 minus 100 divided by 12. Oh, what about 12? On the calculator, we have 90 minus 100 divided by 12. negative 0.83, negative 0.83, rounded. So we're gonna put it right there. Negative 0.83, negative 0.83. Then we can now copy this and put it on our main workbook. We'll come back again to do Z2. So main workbook right here. Okay, Z1. Now let's do the same thing for Z2. Z2 is S2 is 100. Now this is not, it is no longer X1, it is now Z1. And it is no longer 90, it is now negative 0.83. So let's do the same for X2. Transforming X2 using Z2. Okay. Transforming it into Z2. Z2 equals X2 minus mean variance standard deviation. So X2 is 120. Okay. Minus 100 divided by 12. So let's just put it in a calculator and get the answer right there. Okay. We got 120 here. Change this to 120. 1.67. 1.67 rounded. Because 1.62. 1.67 rounded. Yeah. 1.67. 1.67. So I'm gonna copy this and then put it in our main workbook. Now it is no longer Z2. It's no longer X2, it's now Z2, and it's no longer 120, it is now 1.67, which means that the probability that the utility bill is between $90 and 120 becomes the probability that it is between negative 0.83, okay, less than Z less than 1.67. So now what I'm trying to say here is that the probability that it is between $90 and $120 becomes the probability that is between negative 0.83 and positive 1.67. So between the two. To answer that, we need to make our chart. Okay. So here we have negative 0.83. Okay, we got 0 here. Got 1.67. Okay, between them. Okay, we put our chart, which is this one here. The x-axis first. Then the bell curve. Okay, make some adjustments now. Okay, I'm making some adjustment. Okay, then this one, a little adjustment. Now we can now go ahead and put a center line. Okay, put a center line. Right here. Now I put the line that represents negative 0.83 here. One that represents 1.67 on this side. So between them, it will have to shed between them, okay? So you're gonna shed them. Okay, so that's gonna look like. Now, after shedding it, next thing is to find the procedure chart. Okay, procedure chart. So you can find the chart that looks like that one here. You can see that it is this one. To see this chart that look like what we have. This one here. Because this is what we have here. This is what we have. And that one looks like this chart here. So let's say, look at the z value to get the area, add the areas. So we find the area and we add them. That's what it says. And that's what we're going to do. So we got negative 0.83. Remember, negative sign is just to tell you that it's on the left side. So when you're looking at the table, look for 0.83. Don't look for negative 0.83. So let's get to the table. Okay. So table right here. Okay. 0.83. 0.8. Now you gotta go under 3. This is 3 right there. And this is 0.8. To give us 0.2967. You can see right here, 0.2967. Say 0.8 under 3. 0.2967. Okay. Plus. Now we look for next one, which is 1.67. So for 1.6 under 7, 1.6, which is right here, you go under 7. See, 7 right at the top. So for here, go see 1.67, 0.4525. 0.4525. I'll give you the answer for 0.45. So now let's go and put them in. 0.4525, 4525. Okay, let's go and put it in and get our final answer there. So we're gonna have 0.2967 for this one, and for this one we have 0.4525. 4525. Let's go and put this in the calculator to get our final answer on that. We have 0.2967, 2967 plus 0.4525. 0.7492, which is 0.7492. 0.7492. 0.7492. See? And that's how we get it. So that the probability that the bill will be between $90 and $120 is 0.7492. Or you can say that that is you can call it that you can say that there is 74.92% chance that the bill will be between $70 and $90. Yeah. So let's do the last example then, so that we can round up, which is it says find the probability that the bill is more than $140. More than $140. Okay. Again, remember that the mean is the same, and the standard deviation is still the same. So I'm gonna just put it down, and then our X. So this is part C. So the mean is still the same thing. The standard deviation is still 12, but this time our X is what says is more than 140. So our X is 140. Our X is 140, which means that we're going to transform X using the formula. I mean, you're familiar with the formula by now. This one here, that's what we're going to use to transform it. Same formula. I have this right here. So plugging this in, we'll have 140 minus 100. So you have 140, right? Minus 100. Divided by standard deviation of 12. Okay. So we have 1.400. We write it down. Okay. 140 minus 100 divided by 12. Let's put it in the calculator. 140 minus we'll put parentheses here. Minus 100 divided by 12. 3.33. 3.33. You got 3.33, okay? So I'll put it right there. 3.33. So it's no longer X, it's not a Z, and it's no longer 140, it's not 3.33, which means that the probability that the bill will be more than 140 will be the probability that it will be more than 3.33, Z greater than, let's see, the symbol right here, greater than 3.33. Okay, equal. Now, first of all, we draw the graph, please. 0, 3.33. Okay. We can now put the line. Okay. Now we have the bell curve. Okay, right here. Make some adjustments. Okay. Okay. Now I'm gonna put the center line here. The line that represents 3.33 right here. I say it's more than that. So you have it more than that. Okay. Now look for we go to the procedure chart to find the chart that looks like that. You will see that now. I mean, what we have here is this. What we drew, our drawing shows this one here. See on the tail again, right there. So that means that from the procedure chart, we have this is one that looks like that. Hey, the tail right there. So you look at the zebra to get the area, subtract the area from 0.5. So we go and do that. Okay. It equals 0.5 minus a level for the value area for this 3.33 from the table of normal distribution. Okay. So this is right here. Okay, this table right here. 3.33. So I have 3.3. You gotta go under 3. So let's go right there. Yep, 3. 3.33. 0.4996. 0.4996. So I what you got. So you got to subtract that from 0.5. Go to 0.5. 0.4996. And that'll give us the answer to what we are looking for. So you have 0.5 minus 0.4996. So you give me this calculator, give me this number. You give me the number in scientific form. Say 4 times 10 to the power -4. See, raised to the power negative 4 means that there's going to be 4 zeros for the actual number, significant digit. So we have 0.0004. That's what it's going to be. Okay, have that's what will happen here, 0.4996, right? 4996, 3.3. 3.33, yeah. So again, it gives us an answer in scientific form. With this negative, raised to the power negative 4 means that's going to be 4 zeros before the significant digits. So I'm going to take you to that where we can write it down. Okay, so it means 0.0000, see, 4 zeros before this first significant digit. And the first significant digit from the calculator is 4. 4. Okay, so you have it right there. 004. Any question, guys?
I don't have any.
Yeah, on Monday, I mean, when you get a chance, just try this one by yourself as a practice, for your practice. Monday will begin, Tuesday will begin from this finding data value, giving specific probability. But don't go yet. Let me check your put your names, attendance. I got Alan here. Who's this Chadi? Okay, so I see Paul. Okay, it's here. Kate, who's Kate? Kate, you still there, Miss Kate? What's your last name? Oh, I think I found it. Okay, George. I got Subham, Messi. See, okay, I got Messi. I got more. Oh, it's right here. I got H. Olivia. Okay. P. I got Wally. I got Wally right here. Okay, I got Watson. I got it. Teacher B. I got her. Enoch. Say it. Enoch. Say it. Okay, I have it. Adams. Who's Yusuf? What's her name? Full name? Yusuf. Oh, I see it.
Yeah, Yusuf Yagub. It's like near the end of the attendance.
Yeah, I see it now. All right, guys, I see you on next week. Enjoy your weekend.
You as well, Professor. Thank you.
You're welcome. Bye-bye.
Sir,
Yes, ma'am.
did you get me Brianna Campbell?
Campbell. Okay, yeah. Thanks for letting me know. Yeah, I got you now.
Okay. Yeah, I just have my first name. I forgot to put my last name on there.
Oh, probably that's why. All right. Guys, enjoy your weekend. Enjoy your weekend again.
You got Taya?
Yeah. Taya, I got Taya. Yeah, sure.
Okay, yeah. Thank you.
Taya Enoch, right?
Huh?
Taya Enoch, right?
No, Taya Brown.
Yeah, I got you.
Okay, thank you.
Yeah.
You got 8th?
Who?
8th.
Can you say your first name?
8th, like the number.
8. How come I didn't see when you got it? Maybe your name was showing a different name. Yeah, maybe probably yeah. Hold on. Let me see why. Because it is probably showing as a different name. That's why I didn't get. Oh, right here.
Hey, Professor, just to make sure you got my name, Mercy.
Yeah, I got Messi. Mr. 8, I got
Okay.
you.
All right, thank you.
You're welcome. All right, guys.
Hi, do you have Abigail?
Yep, I got a big girl.
Do you have Olivia?
Mapu. I got Olivia Hogan, right?
Yes, thank you.
So, Olivia, are you related to the for ex-governor?
No, but my parents do know him.
Oh, okay. Yeah, I got everybody now.
Have a nice day.
You too. You too. All right. I gotta get up of here.